fast and loud, the thrill of a sonic boom. Imagine a plane, not just any plane, a fighter jet. These are the marvels of modern engineering, designed to slice through the air with precision and power. Now imagine it screaming across the sky, faster than the speed of sound. The sheer velocity is mind-boggling, reaching speeds over 767 miles per hour. That's what we call supersonic. This isn't just a term, it's a phenomenon where the aircraft moves so fast that it compresses the air in front of it, creating shock waves. It's not just about speed, it's about power, technology, and pushing the limits. These jets are equipped with cutting-edge avionics, powerful engines, and advanced materials that can withstand extreme conditions. And that, my friends, is exciting. Pilots undergo rigorous training to master these machines, performing breathtaking maneuvers that showcase their skill and the jet's capabilities. The sonic boom itself is a testament to the raw energy involved. When a jet breaks the sound barrier, it creates a thunderous clap that can be heard for miles. It's like the universe is saying, hey, you can't just break the sound barrier quietly. The boom is a dramatic announcement of the jet's incredible speed. It's a visceral experience, hearing that boom and knowing something incredible just happened. The ground shakes, the air vibrates, and for a moment, everyone is reminded of the sheer power of human ingenuity. The journey to achieving supersonic flight has been a long and challenging one. Early pioneers faced numerous obstacles, but their relentless pursuit of speed paved the way for today's advanced jets. Today, these jets are not just tools of war, but symbols of technological prowess and human ambition. They represent the pinnacle of what we can achieve when we dare to dream big and push the boundaries of what's possible. Behind every supersonic jet is a team of dedicated engineers and scientists who work tirelessly to innovate and improve. Their efforts ensure that these marvels of technology continue to evolve and inspire. So the next time you hear that unmistakable sonic boom, take a moment to appreciate the incredible journey that brought us here. It's a sound that signifies not just speed, but the relentless pursuit of excellence and the thrill of breaking barriers. The wall. What is a sound barrier anyway? Sound travels in waves like ripples in a pond, but invisible. These waves are created by vibrations and travel through the air, water, or any other medium. These waves move through the air at a certain speed, which we call the speed of sound. The speed of sound can vary depending on the medium it travels through and the conditions of that medium. At sea level, it's around 767 miles per hour. However, this speed can change with altitude and temperature. For instance, at higher altitudes where the air is thinner, the speed of sound is lower. Now, as an object moves through the air, it creates pressure waves. These pressure waves are essentially the sound waves that we hear. When an object moves slowly, these waves spread out smoothly. As it approaches the speed of sound, these waves get bunched up in front. This is because the object is moving almost as fast as the waves it is creating, causing them to compress and build up. It's like trying to squeeze through a crowd that's also trying to move towards you. The closer you get to the speed of sound, the more these waves bunch up, creating a significant amount of resistance. This bunching creates a wall of resistance, the sound barrier. When an object finally breaks through this barrier, it creates a shock wave, often visible as a vapor cone around the object. This is what we call breaking the sound barrier, and it results in a sonic boom, a loud explosion-like sound caused by the rapid compression and decompression of air. The first person to break the sound barrier in level flight was Chuck Yeager in 1947, flying the Bell X-1. Since then, breaking the sound barrier has become a routine feat for modern jets, but it remains a fascinating phenomenon of physics and engineering. Breaking barriers: how jets punch through the air. To break the sound barrier, a jet needs immense power. This is where those monstrous jet engines come in. They burn fuel at incredible rates, producing enormous thrust that propels the jet forward. But it's not just about brute force. The shape of the jet is crucial. It's designed to cut through the air with minimal resistance, like a hot knife through butter. The wings are swept back, the fuselage is streamlined, all to cheat the air and reduce drag. Sleek and strong: the anatomy of a supersonic jet. Every part of a supersonic jet is designed for extreme conditions. The wings are incredibly strong, able to withstand the immense forces of supersonic flight. The fuselage is built like a tank, to protect the pilot and sensitive equipment from the intense pressure and heat. And let's not forget the cockpit. It's not just a comfy chair with a joystick. It's a high-tech marvel, packed with instruments that give the pilot complete control over this beast of a machine. The heart of a supersonic jet is its engine. We're talking about engineering marvels that produce mind-boggling amounts of power. They suck in massive amounts of air, mix it with fuel, and ignite it in a controlled explosion that creates thrust. These engines are designed to operate at extreme temperatures and pressures. The materials used are top-secret, cutting-edge stuff that can withstand the inferno inside. It's basically rocket science, but for planes. All this technology doesn't come cheap. Building a supersonic jet is a massive undertaking costing billions of dollars, and that's just the beginning. Maintaining these high-performance machines is another huge expense. Every hour of flight time can cost tens of thousands of dollars. Fuel, maintenance, repairs, it all adds up. But hey, speed has its price, right? And in the world of military aviation, sometimes speed is priceless. So how fast are we talking? Well, it varies. Some jets, like the F-16 Fighting Falcon, can hit Mach 2, which is twice the speed of sound. Others, like the F-35 Lightning II, are a bit slower, but still incredibly fast. And then there's the SR-71 Blackbird, a retired reconnaissance aircraft that could reach speeds of over Mach 3. That's 3 times the speed of sound. It's safe to say these jets don't mess around when it comes to speed. Pushing the limits, the quest for even faster jets. The need for speed is never satisfied. Engineers are constantly working on new designs and technologies to push the boundaries of supersonic flight even further. We're talking about hypersonic jets that could travel at 5 times the speed of sound or even faster. Imagine flying from New York to London in under an hour. That's the kind of future that hypersonic flight could bring. But it also comes with challenges, like extreme heat and pressure, that engineers are still working to overcome. The sonic boom, problem noise pollution, and its impact. When we think about noise pollution, we often imagine the constant hum of traffic, the blaring of car horns, or the loud music from a neighbor's party. However, there's another, more dramatic form of noise pollution that comes from the skies. One of the downsides of supersonic flight is the sonic boom. This phenomenon occurs when an aircraft travels faster than the speed of sound, creating shockwaves that merge to form a single powerful sound wave. It's not just a cool sound effect, it's actually a shockwave that can be incredibly loud and disruptive. The noise generated can reach up to 200 decibels, which is far louder than a jet engine at takeoff and can be heard over vast distances. It can shatter windows, trigger car alarms, and generally annoy the heck out of people. The impact of a sonic boom can be felt miles away from the source, causing widespread disturbance and even structural damage in some cases. That's why supersonic flight is restricted over land in many countries. These regulations are in place to protect communities from the disruptive and potentially harmful effects of sonic booms. Researchers are exploring ways to mitigate the sonic boom, such as designing quieter engines or altering the shape of aircraft. Innovations in aerodynamics and materials science are being tested to reduce the intensity of these shock waves. But for now, the sonic boom remains a significant hurdle. The challenge lies in balancing the benefits of supersonic travel with the need to minimize its environmental and social impact. As technology advances, we may one day find a solution that allows us to enjoy the speed of supersonic flight without the accompanying noise pollution. Until then, the quest for quieter skies continues. Supersonic future advancements and possibilities. Despite the challenges, the future of supersonic flight is bright. Advancements in materials, engine technology, and aerodynamic design are paving the way for faster, quieter, and more efficient supersonic aircraft. We might see a resurgence of supersonic passenger travel, with new jets that can whisk us across the globe in a fraction of the time. And who knows what other possibilities await us in the realm of hypersonic flight. The sky's the limit. Conclusion: the enduring allure of supersonic flight. Supersonic flight is a testament to human ingenuity. It's about pushing the boundaries of what's possible, defying limits and achieving incredible speeds. From the roar of the engines to the thunder of the sonic boom, It's an experience that captures the imagination. As technology advances, we can expect even more incredible feats of supersonic engineering. So buckle up, because the future of flight is going to be fast and furious.